Acids and bases are everywhere. You eat them, clean with them, and even your body needs them to work correctly. Have you ever tasted a lemon? That sour taste? That's citric acid. How about soap? It feels slippery. That's a base at work. Acids and bases are two important groups of chemicals. They have different properties and react in different ways. Understanding acids and bases helps us stay safe and use them properly. Acids taste sour. Think about lemons, vinegar and other tangy foods, or even the fizz in soda. These all contain acids which give them their distinctive taste. Acids have a low pH, usually below 7 on the pH scale. We'll learn more about the pH scale later, but for now, just remember that the lower the pH, the stronger the acid. Acids react with some metals, causing bubbles to form as they release hydrogen gas. Have you ever seen what happens when vinegar touches a penny? The acid in the vinegar reacts with the copper oxide on the penny. It can make the penny shiny again. This is a simple chemical reaction that you can observe at home. Some common acids are citric acid, found in citrus fruits, and acetic acid, which is the main component of vinegar. And then there's sulfuric acid used in car batteries. Be very careful with this one as it is highly corrosive. Remember, never taste or touch anything to see if it's an acid. Many acids can be dangerous. It's best to ask a grown-up or look at the label for safety information. Always handle acids with care and respect. Bases are different from acids. They taste bitter and feel slippery. Think about soap. It feels slippery on your hands. Bases have a high pH. We'll talk about that more soon. Some common bases are baking soda, used in baking soap, which keeps us clean, and ammonia, used in some cleaning products. Be careful with this one too. Just like with acids, never taste or touch anything to see if it's a base. Section 4, the pH scale, measuring acidity and alkalinity. In this section, we will explore how we can determine whether a substance is acidic, neutral or basic. How do we know if something is an acid or a base? This is a fundamental question in chemistry and everyday life. Well, we use the pH scale. This scale is a crucial tool for scientists and anyone working with chemicals. The pH scale goes from 0 to 14. It provides a range that helps us identify the nature of a substance. Acids have a pH less than 7. Common examples include lemon juice and vinegar. The lower the pH number, the stronger the acid. For instance, battery acid is extremely acidic. Bases have a pH greater than 7. Substances like baking soda and household ammonia are basic. The higher the pH number, the stronger the base. Strong bases can be just as reactive as strong acids. A pH of 7 is neutral. It's neither an acid nor a base. This is the pH of pure water. Pure water has a pH of 7. It is the benchmark for neutrality in the pH scale. The pH scale helps us understand how acidic or basic something is. It is essential for various scientific and industrial applications. It's a bit like a ruler that measures how acidic or basic a substance is. Just as a ruler measures length, the pH scale measures the acidity or alkalinity of a substance. Section 5. Indicators. Revealing the secrets of acids and bases. In this section, we will explore how indicators can help us understand the nature of different substances. Indicators are special substances that help us figure out if something is an acid or a base by changing color. They undergo a noticeable color change when they come into contact with an acid or a base, making it easy to identify the pH level of the solution. One of the most common indicators used in both laboratories and homes is litmus paper. Red litmus paper turns blue when it is dipped into a basic solution, indicating the presence of a base. Conversely, blue litmus paper turns red when it comes into contact with an acidic solution, showing the presence of an acid. Indicators are incredibly helpful tools for scientists conducting experiments in the lab, and they are also useful for everyday testing at home. You can easily use them to test the pH of various items around your house, such as lemon juice, which is acidic, or soap water, which is basic. This makes understanding chemistry accessible to everyone.